Alright, so continuing with our transformation chapter, we have done translations, we have done rotations. So we had objects which were moved around and they were rotated. Now we're going to reflect some objects. So we're going to have a line. This is going to be our mirror line, and let's say that we have a point P in one side of that line. So what's going to happen is that that line is going to act as a mirror. So what happens when you have a mirror? Well, you're going to have a point on the other side of that mirror line, right? Those two lines, they are going to be perpendicular to each other, and this length will be the same length as this other one. It's actually, if you notice, the mirror line, it bisects this line PP prime, right? So this means that this length, if I call this point M, which would be the midpoint of this line PP prime, so those two lengths, they would be the same. PM has the same length as P prime M. Now, when you're studying for your IGCSEs, there will be some reflections which will be important. Actually, there's only 3 different cases. The first one is when you're reflecting on the x-axis and on the y-axis. So let's take a very simple example. Let's say that I have a point here. This is a point A, right? So what would be the coordinates of this point A? So x here would be 4 and y would be 2. So this point is 4 and 2. So I could, for instance, reflect this point and use my mirror line, for example, my y-axis. So this would be a vertical line here as the mirror. So the distance, first of all, if this is a vertical line, my mirror line would be horizontal. So since this distance here is 4, my point, my mirror point would be here, which is also 4 units distance from the mirror line, and that's my A prime. And the coordinates would be -4 and 2. So basically it's the same point but with the flipped x coordinate. So this is mirroring on the y-axis. If I mirrored A on the x-axis, then what would flip instead? This would be my mirror line. Right now, this is my axis, my mirror line connecting the 2 points. What I would have here is that this length would have to be the same as the other length. So basically we're going to swap now the y value. So I'll call this, I don't know, A double prime. It would be 4 and -2. So now the value which has flipped is the y value. And it's actually very, very simple to notice, right? It's just like if you have a mirror here, that point would be exactly there. Or if you put a mirror here, you would see this point on that place. Now, we may also have a situation in which our lines, they are vertical or horizontal. However, they are not exactly our x-axis or our y-axis. So how would it look like? So let's say now that my mirror line, all right, I'm reflecting on a line which is parallel to my y-axis. Okay? So let's say that this is my line now. Right? This is a vertical line. It keeps going up and it also keeps going down. So I could ask you, okay, what's the equation of that line? You should all know, right? The equations of lines, they are usually y equals ax plus b. That's the formula, right? That's the how it looks like, where a and b, they are integer numbers, right? Or real numbers. More generally, they would be real numbers. So you can have decimal places, you can have numbers which cannot be written as fractions, right? So if this is your line, your mirror line, well, this is a constant x value. All points in this line, they would have x equals to 3. So this is my reflection line. Now let's say that my point was a 6, negative 2, right? So 6, negative 2. So 6 and negative 2. This would be our point A. Now, if we reflect on that line, this line keeps going forever, right? I've stopped here, but that's just arbitrary. I could continue going downwards, pretend that this is a smooth line, a very nicely drawn line. Okay, so it goes down, keeps going down. Now, the distance from my point A to this line is actually 3 units. And since this is vertical, this line will be horizontal. So it's just 3 units horizontal. So here, 3 units horizontal. And there you go. This would be our A prime. So A prime here would be 0 and negative 2. Right? And it's basically, well, 6 and 0, they are equidistant to x equals 3. Both those numbers, they have the same distance to this number. So how far is 6 to 3? 3 units. How far is 0 to 3? 3 units as well. Well, the last kind of reflection that we usually see is towards either the line x equals y, y equals x, or y equals negative x. So y equals x, that would mean that all values of y and x are the same. So 0, 0, 1, 1, 2, 2. So this is basically this line. A bit tilted, right? But roughly, this, yeah, if this was a line, it would be our line. Okay, so this is our line, y equals x. For all values of x, y is the same, right? If I had a different one, let's say y equals negative x, then it would be this line, in which all values of x, you just flip the sign and you get y. It would be exactly the same line, but 90 degrees tilted, right? So going down here, so the gradient would be same value 1, but negative 1 going down. Anyway, let's consider that this is our line, y equals x. And well, let's say that we have a point here, point A, and the coordinates of this point A are, let's say 4 and 2. So if I plot this point here, here would be 4, and here it's 2. So this is the line, my line of reflection. So if I get a line which is perpendicular to the line of reflection, we would eventually get to this point here, right? So this was 4, 2, and now it's going to be 2, 4. Two, 4. So if you notice from those examples that we've seen, we can actually, well, there's a pattern underlying. So we have reflections on the x-axis, on the y-axis. You may have y equals x. That might be your line, and y equals negative x. So when you flip something, so when you reflect something on the x-axis, what happens is that simply your y will be reversed. So flip, let's say you flip the sign of y. Right? It's obvious when you see this, so you don't have to memorize. However, that's what's happening, right? When we flip on the x-axis, basically you're changing. If y was positive, it's the same thing. Now it's going to become negative. If it was negative, then it's going to become positive. Now this is assuming that it's your x-axis. You're not in any other line. This is the same line as y equals 0, right? This is y equals 0, and y-axis would be x equals 0. So this is basically it's an arbitrary line. In this case it's a particular line, so we will flip y, but if it's an arbitrary y value, then it's going to be something different. Now when x is 0, that's our y-axis, and here it's really similar to the first one. However, instead of flipping the signs of y, we flip the signs of x. And it's obvious if you take a look at a line here, right? Any points that you have here, you're going to have the same one, same height, but only flipping the x sign. Now the last couple ones, when you do y equals x, take a look at the example that we have here. We're going to flip x and y. So x and y, you're going to flip them, right? So x becomes y and y becomes x. Now when you do y equals negative x, you not only flip those, but you also flip all signs. So for example, this point here A, if it was flipped, if it was mirrored, so reflected through y equals negative x, I don't have to draw. I could predict this to be, I'll call this A2 prime, just so we don't have two A primes here. But then I would first flip 2 and 4. So 2 would be here and 4 would be here, and they would all become negative. Now let's try and visualize this here. Y equals negative x would be this line going down here. So we would reflect this point towards this line that we have here. Right? This line here. That's our reflection line now. So if we notice this line, we basically have a distance which is 4 diagonals, isn't it? It's 3 squares down and 3 squares to the left. So we could just repeat the same ratio here. So it's the same square, the same distance, right? So this would be our final points. And if we observe, it's negative. So negative, there you go, negative 2 and negative 4. So negative 2 and negative 4. So let's take a look at a last example here covering reflections. And in this case we have a line, and this is the equation of our line, and this is our mirror line. Alright, so first let's observe this equation. From this we can get two pieces of information. We don't even have to calculate anything. Now look, this is our gradient. It's 2 and it's rise over run. So it means we're rising 2 when we go forward 1. And also this 2 is our y-intercept. So this is our gradient and this is our y-intercept. So since this is our y-intercept, that's the point where our function crosses the y-line, right? The y-axis. However, since our gradient is 2, if I go 1 forward, I would go 2 up, and then 1 forward, 2 up, 1 forward, 2 up. So, and if I go 1 backwards, I would go 2 down. So 1 backwards, 2 down. So we can actually already have an idea of how our line is gonna be like. Right? That's roughly how our line is gonna be like, and it keeps going up and down. Now, what about our mirror line? So our mirror line is x equals to 1. So this is x equals to 1, and for any y, I'll basically have the same value of x. So this is our mirror line, x equals 1. So how would our reflection look like? So we can observe any points that we know. For example, this one, which is our y-intercept. If we just look at our line, it's 1 unit away, 1 unit distant from our line. So if we reflect this point, it would show up here. Likewise, this point is 2 units, so it would show up here. This point is going through the mirror, so it would remain at the same place. So we can already see how our line is gonna look like. So our reflection is this red line here, and also it keeps going down, keeps going up. Now what if I asked you what's the equation of this line? Well, this line, since it's the same gradient as the one before, but now it's the same logic, but it was going 2 up while I was going 1 to the right. Now it's going 2 down while I'm going 1 to the right. So if I go to the left, I'm going 2 up. So if here is height 4, here was 2, I went up by 2, and then here when I go back, I go up by 2 again. So this would actually be 6. So I know that my graph, right, my function, my line would be something ax plus 6. There is some mathematical way for you to find the gradient if you know the two lines are perpendicular. If you know that, right, basically that means that if you multiply, well, in fact we can do a equals rise over run. That's the easiest way. So if we do rise over run, so let's observe our line, our reflected line, so the red one. So we're going 1 forward and 2 down. So rise is -2 and run 1. So that's -2. So we know that a is -2, therefore the equation of our reflected line would be -2x plus 6.